Hello and welcome to this lab demonstration video on monitoring memory performance. At the beginning of this lab, we already need to be familiar with the concept of VMware vSphere ES6 Top CLI utility. In this lab, we are going to generate a database activity in a test VM. Then we will check for overcommitment of VM memory. After that, we are going to configure ES6 Top utility to report VM memory statistics and observe it. And finally, we are going to start a memory test and record memory statistics again. I'm sure I provided you enough good reasons to watch the following video on monitoring memory performance. So let's get started. At first, in the beginning of this lab, we need to go to our menu, hosts and clusters. And let us start our first test VM, which is gonna be Linux 01 VM. So let's right click on it. Let's choose power and power on. Now we are going to wait a bit for us to be able to launch its web console. So let's click on it. What we are going to do right now, we are going to let this VM to actually load its operating system, and then we are going to launch a specific pre-configured test application, test program, which is going to be a test program which performs continuous database operations to a medium-sized database. So we are going to use this as some kind of memory-heavy workload to actually produce some kind of RAM operations, which we are going to impact a little bit later during this lab. So let us wait a bit for this VM to successfully load up. Just a couple of seconds. And a couple of seconds more. Now it's ready, so let's log in it. Let me click here. We are going to log in as root. Let's type our password. And now we are going to launch the RAM activity script. Let's call it by typing start test 2. Now we need to wait a couple of seconds for this program to successfully begin. As long as we see our first report about some operations per minute activity, this program is up and running. So now we see it. We see that currently this program generates somewhere around 1,800 operations per minute. We can see it by checking the value of OPM parameter here. Now it's growing a bit. So we are going to leave this application to work for a couple of seconds. Now let's go back to our vSphere client. Let's choose our Linux 01 VM. Let's click on Monitor tab on the right side of the page. Let's go to Utilization section of the Monitor page. And now we can see two types of memory data about this VM. We are mostly interested in two parts: virtual machine memory and guest memory. Here we can see two types of recordings. The first one is VM consumed amount of memory and active guest memory. What are we going to see here? We need to wait a bit, somewhere around a couple of minutes, for us to be able to see that VM consumed value will grow more than the active guest memory value. This means that our ESXi host provides our Linux 01 VM with enough memory to operate. We can even periodically refresh our vSphere client page for us to see that this number, VM consumed, will actually grow up more than maybe 60 megabytes. Then, if we see that the VM consumed amount of memory will become more than active guest memory, then we can decide that this VM does not have any memory overcommitment. So let's leave this page untouched. We can return to it a bit later, for example. Of course, we can periodically refresh the vSphere client page. Now we can see that VM consumed is already almost 700 of megabytes. Our active guest memory is currently set to 741 megabyte. So we can even wait a bit more. Let's return to our Linux 01 tab. Here we can see that the current level of operations per minute is more than 2000 of operations. It's almost 2200 operations per minute. So let's remember this value. Now, what we are going to do next? Let us connect to our SA ESXi04 host. If we click on our Linux 01 VM and go to a summary tab, we can see that our Linux VM is currently being launched on SA ESXi04 vClass local ESXi host. So let's open our multi-party application. Let's connect to our SA ESXi04 host by double-clicking it. So currently we have connected to our ESXi host by using SSH. And let's launch our ESX top utility for us to be able to monitor some memory activity of our VM. For doing that, we need to launch the ESX top utility. Now, let's set its refresh interval from 5 seconds default value to 10 seconds value. For doing that, we need to type S letter here, and then we are going to set a level of 10 seconds for refresh interval. Now, we need to press simultaneously two buttons right now. Those are Shift and V, for us to filter only the VM information without any other memory activities of this particular ESXi host. So now we can see our Linux 01 VM with some values of memory information. Now we need to filter these statistics. We need to drop some columns from this particular, let's call it a table, and we need to add some values. For doing that, we need to press the M letter here. Now we can see the information about the memory of our ESXi host, memory consumed by different applications and daemons. So now we need to press a Shift-V combination. And now we can see the memory statistics only about our Linux 01 VM. So now we are going to filter it. Let's press the F button. And now we need to drop some columns from our table. We are going to leave only 4 letters here: D, H, J, and K. D stands for name, H stands for memory size, K stands for swap statistics. We are going to use it a bit later. And J stands for memory control, or memctl. So for unsigning some metrics from here, we need to type those letters. For example, currently I'm going to drop the B statistics, GID or group ID. So I'm typing B here, and we can see that the asterisk sign disappeared from our B letter. Now I'm going to leave D option enabled. H option is enabled. I'm going to enable J option, memctl, so I type J. Now I need to leave K option, swap statistics, so I do not press K. And I need to drop away the L and O options. The L option stands for LL swap statistics. Our ESXi host does not use any SSD cache for placing VM swap files on it, so I do not need this statistics information, so let's type L. And now I'm not going to analyze any information about memory overhead here, so I type O and press enter. So now we can see some changed information about Linux VM. We can see only its name, we do not see its GID anymore. We can see the allocated memory information, we can see some information about possible using of balloon driver, and some information about swap statistics. Currently, our virtual machine does not use any balloon techniques provided by balloon driver, which is included in VMware tools, although our virtual machine is configured to use balloon driver if we need, or our ESXi host can use a balloon driver inside this VM to reclaim some RAM. The maximum amount of memory which can be reclaimed is more than 500 megabytes, but currently it's not used at all, and our virtual machine does not swap any memory pages. So the statistics about currently used amount of swap is 0, and swap writes and swap reads and swap writes are also 0. So what we are going to do next, we are going to leave this page untouched, and now we are going to create some resource hog for our ESXi host 04 and our Linux VM 01. What we are going to do, we are going to launch 2 additional virtual machines, Resource Hog 01 and Resource Hog 02. But before doing that, we need to verify that both of those VMs are located on our ESXi 04 host, near our Linux 01 VM. For doing that, we need to click, at first, let's click on Resource Hog 01 and let's see that this VM is located. In my case, it's already located on SA ESXi 04, and our Resource Hog 02 is located on ESXi 04.2. If you see a different result here, if your Resource Hog VMs are located somewhere else, we can just migrate them on our ESXi 04. We just need to right click on any of those VMs, for example, Resource Hog 01. We need to click on migrate. We need to choose the change compute resource only for changing ESXi host. Click on next. We need to choose our SA ESXi 04, and then we need to continue this wizard up until the end, up until the finish button here. I'm not gonna do this because my VMs are already located on SA ESXi 04, but we do not need to select any other networking information instead of default, and so on. So I'm gonna click cancel, but you may need to migrate those VMs to our ESXi 04 host. Next, what we need to know here, what we need to remember here. I'm going to start both of those VMs, Resource Hog 01 and Resource Hog 02, but we need to do it in series. I'm going to launch a Resource Hog 01 VM, then I'm going to launch its web console, and then I need to catch a specific phase of this machine loading. I need to load some specific utility before the actual operating system is going to start. So what I'm gonna do, let me show you. I'm going to power this virtual machine on. Next, I'm going to launch its web console. Let's go to that VM tab. Now I'm waiting to see a specific word on the screen, which is boot. Now we need to press enter. And our Ultimate Boot CD application has been launched. If you were not successful to press the enter button during the boot phase, for which you have only 30 seconds, you can restart that VM and actually allow it to boot the Ultimate Boot CD application. Here we need to choose a mainboard tools. Now I'm going to memory tests, and now I'm going to launch a memtest 86 Plus version 1.70. Let's enter. Now I'm going to repeat those steps for my ResourceHog 02 VM. Again, I'm going to power it on. I'm going to launch its web console. Again, I need to wait to see a boot word on my screen and press enter as long as I see it. And here it is. I'm pressing enter. Again, I need to choose a mainboard tool, memory tests, and I'm gonna launch memtest 86 Plus version 1.70. And now we can actually wait for a couple of minutes for both of those VMs, ResourceHog 01 and ResourceHog 02, to actually warm up. Currently, those VMs are going to generate some memory-heavy workload for us to be able to see that our Linux 01 memory statistics have been changed. So let's give those VMs a couple of seconds. During that, we may go back to our Linux 01 tab and see that the number of operations per minute can reduce. I still see the value significantly more than 2000 of operations per minute. The last value was 2109 operations per minute. So the next value is, the most fresh value is 2081. I expect this value to drop even more. So it's slowly dropping to 2054, 2028, and so on. While our ResourceHog utilities are actually working right now. So what are we gonna do next? Let's go to our ESX top back, our ES6 top utility back. Let's click on our multi-putty again. Here we can see that our ES6 top memory statistics has been changed because of addition of two VMs, ResourceHog 01 and ResourceHog 02. What I'm gonna see here, let's again see the MCTL column in this particular table. Again, the Y sign here signifies that our Linux 01 VM can actually use a balloon driver. Its balloon driver can actually be used by getting some additional RAM by our ESXi host from this VM, and our ResourceHog 02 and ResourceHog 01 virtual machines do not use any balloon driver in it. So what we can see here next, we can see here that now our Linux 01 VM has some amount of memory ballooned by a balloon driver. So with a maximum possible balloon memory somewhere around 565 megabytes, we can see that already 300 and almost 50 megabytes of this ballooned memory is consumed or reclaimed by our ESXi host. And now we can see that our Linux 01 VM still has near zero level of swap writes and swap reads, but our ResourceHog 02 and ResourceHog 01 are actually doing some swap operations. Swap writes and swap reads are not near zero. what we can actually see here even more. Let's change this statistics information from memory, from RAM to CPU. Let's type C letter here. Now the information has been changed to a CPU information. Again, we only see the information about our 3 launched VMs, Linux 01, Resource Hog 01, and Resource Hog 02. Let's see that our Linux 01 VM has a very small level of a so-called swap weight value. The time our virtual CPU of this VM spent in a swap weight state. But our Resource Hog 01 and Resource Hog 02 both have a significant amount of CPU time spent in this value. Actually, this number, more than even 5%, must be considered as a problem, and some level of memory overcommitment of a particular virtual machine, and so on. So be very careful when you actually see those numbers more, and like here, significantly more than 5%. So we need to maybe perform some countermeasures according to our RAM needs in those VMs. But because of this high level, this enormous level of swap weight, our virtual machines can degrade significantly in compare with the normal state of those VMs. So let's return to our memory statistics back. Now we can see that our ESXi consider itself to be in a clear memory state. We can also see during these tests that our ESXi host can turn it to a soft state. Those states show us in which level of memory overcommitment our ESXi host currently exists. So clear state means that our ESXi host is only going to use a transparent page sharing technique to receive some additional RAM for our VMs and for itself. And the soft state shows that our ESXi host is dynamically using balloon drivers in our launched VMs. Here we can see that our ESXi host can only balloon some some RAM from our Linux 01 virtual machine, because our Linux 01 is the only VM with this option enabled, with VMware Tools set of drivers installed. So, and in the end of this lab, let's go back to our Linux 01 VM and let's see the level of operations per minute. So now the average level of operations per minute has become somewhere near 1,400 operations per minute, in compare with 2,400 operations per minute, which we have seen in the beginning of this lab. So now our lab is completed. Congratulations, you have completed the monitoring memory performance lab demonstration video. During this lab, we have seen how and where we can check for overcommitment of a VM memory, how we can configure an ESX top output to report VM memory statistics. Then we have seen how we can start some memory tests on 2 of our VMs, and finally how we can record memory statistics. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware world.